So today we have two speakers, José and Andres. They are both working at Expert.ai. I will let them present much better than I would do. The idea is to have more of a discussion. Also, they will talk around the following topics. So probably a bit of background on how they came to AI and also to apply AI in the space industry for the European Space Agency in a study. They may also introduce their company as well. We may talk about the language model size that is ever increasing. You've probably seen all of the LinkedIn posts about a new release of a model with X billion parameters. So what does it mean? What roles does it play? Maybe some of you came following the hype of ChatGPT as well. There are some new approach. It's also an occasion to talk about the implication and possibly the connection with knowledge graph and language model.
Okay.
All right. And yes, José, Andres, first, I'm really happy to have you here in this discussion. I kind of also started AI because I'm very interested into the possibilities of NLP. So yeah, let's dive in, and I'm really curious to hear what you can tell us about NLP for space.
Well, let's get it started, and we have thought of a few ideas that we wanted to share with everybody. But of course, any questions, any comments, any discussion, or any thread that may be interesting, just we can just follow that and focus on that. I think I will start by sharing my screen and maybe introducing the company, or maybe I should try to follow your agenda and say how we started working in NLP and space, because that's kind of a motivation for everybody here apparently.
Yeah, I'm really curious.
Yeah, I mean, we work for a company that has a very philosophy that is focused in pretty much in a technological viewpoint of AI and different areas of AI involving with focus on NLP, but also other areas like knowledge graphs and so on, semantic technologies. And the department of the company that I work for, the R&D department, and particularly our group, is very focused on different areas of research in that direction, understand the language, and also in seeing how we can make an effective use of language for different purposes. In 2014, we were working in projects that were slightly different from the kind of research and development projects that we're working at the moment. And then somebody contacted us because they were trying to set up a project related to space and that involved some capabilities that we have been working on for several years. And they were interested in the work that we had done in that previous project, a European project that was related to digital preservation and long-term preservation of scientific investigations and these kind of things. A project that was called Work for Forever back in the day. And this person happened to be working with ESA. And they were setting up this new cool project that was called Everest. And the idea that they had there was to develop some kind of virtual research environment where different scientific communities working in Earth observation, Earth science, and so on could work together, could collaborate, could exchange information could extract information from their documents and from the data sets and put it all together and preserve it so that anybody in 30 years time, for example, could take the data and reproduce their experiments or their observations and so on and so forth. So that's the first time that we started working with communities involved in space, and particularly in Earth observation, looking at the Earth from satellites around us. And one thing that we did in that project was to see, okay, all these, there's a big problem related to these, all these resources, all these data sets, and this code for experimentation, for observation. And it's that it's very difficult to find automatically, with machines. It's not accessible, interoperable, reusable. It's very difficult to type a query somewhere under these data sets or this code somehow pops up. And we realized that a very important problem that this had was that there was actually not a lot of metadata that was exported or that was offered so that machines could actually understand what is the content of those pieces of information related to Earth observation, Earth science, and these kind of things. So what we did there was to apply AI, particularly natural language processing technologies, to extract information from the documents contained in those scientific investigations by these communities. There were communities from volcanology, sea observation, sea monitoring, natural hazards, all this. And we extracted that automatically through NLP, and we exposed it in a way that was much readable. And that was the first thing that we did in space. And from there, we started a collaboration with ESA, working in different problems, ranging from knowledge management to mission design to quality assurance, these kind of things, where the application of artificial intelligence and NLP was very, I mean, everybody understood that this could have some value, but we needed to show what that value could be and how it can help solve actual problems. And that's what we are still continuing that collaboration, and we hope that it will last many more years. Very exciting field to work in.
All right, thanks, José. Yes, indeed. And for people that are from far or not from Europe, when we refer to ESA, we refer to as a European Space Agency, who's coordinating activities related to space. So it's the equivalent of NASA in Europe, we could say, I think. Okay, and maybe Andres, do you want to say maybe a few words also on how you came to work to this project, or what's your background on NLP?
Okay, I could say a few words. Mostly, let's say that I have a parallel and research background with Jose. I also had a background with semantics technologies, knowledge graph, and so on, and NLP. And we have been working with this, as he said, like from, I don't know, since 6 years ago, I guess, in different projects. We have tackled problems from information retrieval, knowledge preservation, and at the end, what we are doing is just to easy the access of the information that they have, particularly in text. And as you know, the agency produces huge amounts of text, and most of them are in PDF documents. So the challenge is how to easy the access to that information. And I think we are working on that direction. And what we plan to show you today is related to that goal.
Oh, great. Yeah, I'm excited. I started to work in the space industry myself, and having to deal with so many.
We lost you, Patrick.
Yeah.
Well, can you hear me?
Oh,
Hello?
now we can
Can
hear
you
you. Yeah, yeah.
Yeah. If you are lucky, you have PDF.
Oh, yeah.
You're right.
Yeah.
Otherwise, they may be a scan.
Exactly.
Yeah, we've suffered that. I mean, we have all this data that is here available for processing with NLP techniques, AI, and so on. And then it's images.
Yes, and also in addition to the document format, the other challenge that we face in this kind of organization, which are very big, is that the data is in silos. Data is scattered around different systems, different databases that don't communicate with each other. So that's another thing where interoperability and these issues needs to be faced.
Mm.
Okay.
Yeah, I think maybe a reflection of what we are now in this landscape of application of AI and natural language processing and understanding technologies is that, for example, or at least I see that there are three main levels where we have AI that helps you extract information from content. Then we have in a more advanced level, we have AI that helps you understand, or that is able to understand somehow the content, the text in our case mainly, and is able to, for example, answer questions or generate questions or summarize documents, these kind of things. And then we have eventually in the future at some point, probably not too far away, AI that is able to do some tasks, scientific or engineering, technical tasks independently. For example, imagine writing a grant or formulating a scientific hypothesis. This kind of high level in terms of cognition tasks that are until now associated only to human scientists and engineers. So right now, I think that we are somewhere between the first stage and the second stage. We are, although there are many applications already in the second stage, and we are having a glimpse of how these autonomous AI with high level of cognition would be in the coming years.
Yeah, sure. I also have maybe a quick question. Is what kind of background? Do you have an academic background, both of you?
I think, well, both of us have been on both sides of the spectrum. I would say, both in industry and academia. Yeah, so it's I think it's a kind of a hybrid background. But me personally, I've been most of the time I've been in industry. Yeah, and Andres, you too, right?
Yeah, it's the same for me. What is I think important is that as we have that academic background too, we like to publish our work. So you will find the papers describing the application that we are going to present you today. Some of them are publicly available.
Oh, that's great. So I will try to switch my internet connection to a more stable one. I hope nothing breaks. And then we could move on to the actual presentation of this work, if you want.
Sure.
Okay, so everyone, please finger crossed for give me 2 seconds.
At least Patrick is smiling.
And we're still here.
We're still here.
1, 2, 3. I'm back. Right.
Hey, you made it.
And okay, it didn't work. And now I think it will be much better. So sorry for the inconvenience. Okay.
Okay. Let me share my screen here. I mean, like I said at the beginning of the talk, we don't really have. We're not going to give a conventional kind of talk. We don't have slides. We're just going to talk about this whole our experience here, and we're going to show you some hopefully cool stuff. So the company we work for is called Expert.ai. Both Andrés and I work for the Language Technology Research Lab, which is based here in Madrid, but we have collaborations with the company all over or in many different places of the world. Expert.ai was founded in Italy, in Modena, but then it expanded through Europe, and also it also has a strong presence in the States, which is growing or has grown a lot in the last few years. But the purpose has always been more or less the same. It has been to understand language, to extract value from language, and to solve our problems, to solve related to information management for our customers, including space, but also many other domains like, for example, the financial domain, life sciences, defense and intelligence, many different domains. I have to say the company has been around for 30 years. It sounds incredible. We neither me nor Andrés have been there from the beginning, but yeah, it's a long time. So we're going to show, well, this is an overview of a platform, which is, I mean, the technology that we use is what we call hybrid NLP, or that's the approach or the philosophy. Most of the technology stack originally comes from a symbolic or structural point of paradigm, where you have like a node graph and you have rules, and those rules help you extract information from text, or also do things like categorization, classification, these kind of things. But there is also an increasing hybridization. So this is working together with many methods coming from the deep learning side of things. Of course, language models and so on and so forth. Actually, a couple of years ago, we published a book with Springer about this, which is called A Practical Guide to Hybrid NLP. And there we provided a lot of examples how you can put the different pieces together, so that you can use knowledge graphs and language models and embeddings and all these in order to solve problems effectively. So if I click here on APIs and connectors, we will see, for example, the Expert.ai NL API, natural language API. So this is an API that we are offering that anyone can go to our website and try it, and it's a very cool toolbox to do text understanding work, actually. So among the kind of things that you can do with this is, for example, to resolve ambiguities in the text. So we have a disambiguator that works on top of a knowledge graph, lexicosemantic knowledge graph, similar to Word, for example. That's what we use in order to do disambiguation. It's also possible to extract information, concepts, occurrences of the concepts from the knowledge graph that appear in the text, phrases, name entity recognition, relationships, and so on, sentiment analysis, categorization, and so on, and all these kind of things. And this is available online, and you don't need to do anything in particular to try this. So this is the demo. There is also a Python library that you can use from your own code in order to try these kind of things. But from the demo, I mean, you have different types of text processing that you can do. You can analyze the document, play with document classification, information detection, like for example, personal information detection, or also this kind of stylometric analysis, for example, where you can extract features from the text written by a person, which somehow can be related to the style of writing that this person has, no? That kind of thing. We click on document analysis, and we pick one of these texts that we have here. For example, this one about José and Andres, and click on analyze. Here we have a very complex or detailed linguistic analysis of the text that is contained there. It's, like I said, it's a text about José and Andres. We can see, for example, the phrases that are contained in that piece of text. For example, I have a noun phrase here, which is about Charles Bronte, or verb phrase, which is having invited. I can also see the part of speech, dependency trees, for example, here. So a lot of linguistic information at the lexical, syntactical, semantic level that we're not going to get into details right now, no?
Okay. So this is, for example, some of these tools, you could use it to then build a knowledge graph out of the text that you analyze, the ambiguity that you resolve.
Mm-hmm. I mean, that's a use case. I mean, a use case that we are doing some projects is to use this technology to extract, for example, the entities from a piece of text, the relations between those entities, and then you can build eventually you can build a knowledge graph by connecting those entities and those relations. But the usual way in that knowledge graphs used in this kind of pipeline is that you have a knowledge graph underneath, which is your knowledge base, basically, with a lot of concepts and the relationship between these concepts. And then thanks to that knowledge that is previously structured, you're able to do things like word phrases ambiguation. I mean, you have
Can you give an example of disambiguation?
Imagine that you have a text that is talking about cars, and at some point the brand Jaguar is mentioned there. Jaguar, if you don't have the context, could be a car or could be an animal as well.
Mm.
So the what we call word disambiguation in this case would be to identify the right concept that belongs to the surface form of Jaguar in that particular text, right? So that's the idea.
Okay, thanks.
So, and we can see here in the key elements, what we call key elements. You can see the main topics of the text. You can see the main lemmas, main sentences, main phrases, main concepts. But I want to, rather than going deeper in this demo, which is general purpose, I think something that may make more sense is to go to a specific demo, which is focused on the domain of earth science or observation and related to space. So, for example, this one here. By the way, I invite everybody in the audience to take a look at this demo, because there are many more things that you can do than just it. You have sentiment analysis, well, many things. Just take a look and play with it a little bit and try to break it through. Okay, For example, in this case, this is what we call a document enrichment demo, and it's related to what I mentioned before about extracting metadata from a scientific text and exposing it in a machine-readable way, so that machines can actually, for example, a semantic search or recommendation. You can build this kind of tools on top of this metadata. So, for example, here we have several examples of abstracts from scientific papers. For example, these are models about Campus Gray, which is about volcanology, the evolution of marine noise pollution management, or the study of the impact of lockdown on nitrogen dioxide levels in Europe.
So just to understand a bit the context, these were sort of at the basis, it was Earth observation data that were studied by scientists, and they produced a report according to these observations. And this is what we analyze here, right?
Yeah, it can be technical reports or scientific papers or a field note or any piece of text that you want to analyze related to the domain. The interesting thing here and the sense in which this demo is different from the previous one that we saw, the corporate Expert.ai NL API demo, is that this works on a knowledge graph, on top of a knowledge graph that has been customized or extended, adapted for the Earth observation and Earth science domain with help of the European Space Agency, who contributed also several resources to make this possible. So if we click here on analyze, this is a text about pollution and how the lockdown impacted on pollution in Europe, the COVID-19 lockdown, of course. We can see here the different things that we can analyze. We have topics, key elements, entities, and something that we call standard analytics. We will show a little bit of this later. So in terms of topics, we can see that this, according to our knowledge graph, this text is about, it says it's about meteorology, which in a way is true, but it's not very accurate. It's very general. But we also have a taxonomy, in this case coming from IPTC, which is a typical taxonomy that you can see in newspapers, with different levels of political. Here it says that this is more about weather, environmental pollution, in addition to meteorology, and contradiction and wages. And then we have two more taxonomies, which are fields of research and the NASA subjects and scope taxonomy. Fields of research is used by Springer Nature. And here, where our classifier says is that this piece of text is about atmospheric sciences, which is a subclass of our sciences. And if we click on NASA subjects and scope, it says that this is related to environmental pollution as part of geosciences. So this is the topics, just the topics, or the domains that this text belongs to. If you click on key elements, we can see the main sentences of the text, which are the sentences that contain the largest amount of information of this text. It's a type of summarization. Of course, this is not a very long text, so that doesn't really have a lot of impact, but it's useful when you have longer tests.
Yeah, indeed.
When
was this prototype developed? Because the pace at which NLP tools are developing is, it's super quick. So maybe can you give a context of when this was?
This was developed very recently, and I mean it's based on the technology that we have in Expert.ai, an evolution of that, and the customization of the knowledge graph for Earth science and Earth observation, which has been happening during the last 5 years. But some of the functionalities that we've seen, that we're going to see here, have been developed in the current year. I mean, by the end of 2022. So it's actually quite new. Well, you have main lemmas, which are canonic representation of words. We have the kudos and so on, and phrases, which are multi-word expressions, or the main concepts that come from the knowledge graph once the text has been disambiguated.
Yeah, if I may say something, Jose, some of the things that you have shown, specifically in the topics part, like the fields of research or the other taxonomy, the NASA scope and subject taxonomy, those have been developed with neural networks, classifiers using neural networks. So because there were data that allow us to train those classifiers.
Yeah, exactly. Actually, this is just a knowledge graph. These are rule-based projects for categorization. This one, UPTC media topics. And this is what Andres is saying, a neural network-based classifiers based on these taxonomies and the data that we get annotated according to those taxonomies. For this, we use language models. We use transformers in order to implement both of these. Okay. Then we also have things like we are able to extract entities, type of entities like places, countries, and so on. And these are linked. For example, Italy. This is linked to geonames and Wikidata. Okay, and this comes from the knowledge graph, and also time reference, which is actually quite useful. You can extract the different time spans that are mentioned in the text. Okay, let me see another example here. Okay, for example, this one.
So what would be so when we can get this information, this entity, what would be a follow-up use of this general, or do you know already what user would do with this in general, or is it still an exploratory work?
Well, this is being used very much for analytics purposes. When you, for example, you want to visualize, typical applications to have a dashboard with all these. Imagine you have a collection of documents, and you want to have a statistical representation of what is contained in those documents. So you extract the metadata and visualize it. You have your tag cloud. You have some way to interact with the data in terms of what are these documents talking about. That's the typical type of information. Maybe, Andres, you want to comment?
Yes. Well, in addition to that, you can use all this metadata, for example, in a search engine, so that you can use, for example, the entities as facets. So you will have a faceted search. You will say, okay, I'm interested only in documents where location China is mentioned, plus between this date and this date. So all these metadata can be integrated in search engines as facets, and also in recommendation systems, because you can base your recommendation not only in text similarity, but in entity similarity, or in any or topic similarity. You want to recommend other people interested in documents based on all this metadata. So actually, this is something that we have done in other projects, integrated this metadata in search engines, in recommendation systems, and as Jose said, also in visualization. To help users to browse large documents collection in an intelligent way.
Yeah, and also another interesting case that we developed with ESA was related to intelligence. Not only with ESA, but with many other customers related to intelligence. For example, imagine that you want to see. We have a view of the current publications that appear in some about a particular domain, or that mention a particular satellite or an instrument or these kind of things. What we have done at some point is we have a platform that is able to harvest a lot of information from online sources, and then you can the platform offers a way to visualize all this according to different dashboards, and be able to see how, I mean, what are the trends of within this information? How what are all these? For example, I have all these papers talking about MBSAT. What else are they talking about? You know, or that kind of things.
Yeah. Okay.
Or what agencies are publishing papers related to this and that instrument? Or
what are the emerging research topics
exactly.
that are using my information? No, that was a use case that we had.
Yeah. Also for collaboration between different agencies. What are these two agencies collaborating in?
Okay, yeah, it's this general desire to get quicker access to the information we generally need. So okay, great.
Okay.
We have maybe one question. Maybe we could take, and I encourage people if you have specific questions or more generic one to put them in the chat. So how the knowledge graph is created, and it is created for each document? No.
The knowledge graph is a resource that helps you understand text. Typically, that's the use case that we have. Bear in mind that developing, I mean, this kind of knowledge graphs contain about 300,000 concepts and millions of lemmas and relationships connecting the different concepts with each other. So it takes a lot of effort to develop a knowledge graph this deep and wide. So it's a resource that you use in order to be to have a better understanding of the information. That's the main purpose. And not only these knowledge graphs that we are using here, but in general, the knowledge graphs that are available out there, like Wikipedia, DBpedia, Wikidata, these are knowledge graphs as well. Different type of knowledge graph, but it's a knowledge graph, and there is a lot of effort across many years to build these knowledge graphs.
Okay, thanks.
Okay. More questions or?
Not for the moment.
Okay. We also have this integrated thing here, which is, like I said, very recent about extended analytics. And here we have things like identifying the challenges or problems that are mentioned in a piece of text and the solutions that this particular imaginary article, scientific article, is proposing to address these problems. For example, we see here that the red thing has been identified to be a challenge. In March 2020, the World Health Organization declared SARS-CoV-2 an infection, a global pandemic. We know it is a challenge, it's still a challenge. And then a solution or an approach that was proposed here in this paper to deal with that was to describe in particular the origin and the diffusion of COVID-19 in a particular place in Italy, underlying how the geographical circulation has been heterogeneous and the importance of pathophysiology in the involvement of cardiovascular and neurological clinical manifestations. So more than a solution, this is kind of a proposal, a research proposal related to this challenge that we identified before.
I see.
Also, and this is built using a number of language models that have been fine-tuned on particular data sets for challenge and solution extraction from text or from ideas. And all the things that we are able do, or what we can see here, is we have this text, and our model, we have a model here that's able to extract or generate a question that can be answered with information described in the text. So for example, here the model feels very confident generating the question, what is SARS-CoV-2? And here we have the answer to that question, which is severe acute respiratory syndrome coronavirus 2.
So that's interesting, because here we are generating a question. Why would want in general to generate question? Could it be to build a FAQ, or I don't know? What can you tell about this?
Yeah, Andrés is going to show later on a demo which is focused specifically on question generation, and another one which is focused on question answering. But I can anticipate something which I think is very useful about question generation, or in general natural language generation, but question generation in particular, which is a way to help the reader have a better understanding of the text that is being read. It's related also to summarization techniques, because it requires some kind of understanding of the text that the model has to do. And this understanding is reflected in the question that the model generates. So what this is telling you is that this text is about SARS-CoV-2, because it's a question that can be answered with a context here. Imagine that instead of just one question that we have here, we have 3 or 4 questions for a longer text. That's a kind of help or aid to understanding that content. And in a very complicated text like scientific literature, I think it's very important to learn to make the right questions. No?
Indeed.
Okay, and another thing that we can see here is claims. So claims understood as the main statements that are being made in a piece of text. For example, here it says that the coronavirus disease was first reported in Wuhan and has been associated to novel coronavirus, blah, blah, blah. And then we have another claim, which is in March 2020, the WHO declared the SARS-CoV-2 infection a global pandemic. So these are the main statements that we have extracted from this piece of text. And what we can see here on the left is for each of the claims in the corresponding color, what we see is other claims that have been extracted from the scientific literature that somehow are related to these claims, which can support, refute, or simply related to the claims that we extracted from the text. So for example, here we have the coronavirus disease, a variant of SARS-CoV-2 originated in Wuhan, which is basically the same claim that is made here. Or the new coronavirus disease was first discovered in Wuhan in December 2019. You see, it's super related. And so this can give you an idea of whether these claims that we are extracting from this text are supported by the literature, by the existing scientific literature. Not only that, the system takes you to the specific publication with that supporting, refuted, or simply related statement has been published. So it's a way to do fact-checking on scientific statements. That's a little bit the idea.
That's really cool. I can even think in the space domain, when we have many documents, we also would like to verify some claims. Let's say you would like to verify, there are some claims about the remaining margin for the battery capacity, and in this given model, maybe you would like to verify that it does not contradict with what is stated in an analysis document or something like this. So
yeah, Yeah, definitely. This is something that we are applying in space. For example, in relation to the OSIP platform, the open space innovation platform. We recently finished a project which was about being able to understand the ideas that people submit to the open space innovation platform for funding to make the life of the evaluators easier. No? And part of that work was included this claim analysis, and also this part that we saw before about extracting the main challenges and solutions that are described in the text and so on and so forth.
So yeah, to kind of study the relevance of some novel ID proposal to be funded by the Open Space Agency.
Yeah, you want to see if there are other ideas or other projects that have been funded that share similar challenging solutions, topics, and so on. And if that's the case, maybe what you're proposing, your idea is not so innovative anymore.
I see. Okay, we have 2 quick questions. Then maybe we can give the floor also to Andrés, or let's see. So is semantic web technology related to knowledge base? Or maybe, Spurio, you meant knowledge graph? So yeah, that's one question. If semantic web technology is related to a knowledge graph, does that ring a bell?
Yeah. Yes. The answer is okay. Yeah, the answer is yes. Actually, knowledge graphs are very related to semantic web technology, and in semantic web, the semantic web community proposed a number of vocabularies that are used to build knowledge graphs everywhere. And it's actually a way to make knowledge bases more expressive, more interpretable, larger, and easier to maintain.
Thank you. Constantina is asking, probably in the previous use case, so maybe question and answer generation, what is the score parameter representing? Is it a similarity metric, or is it, and if it's used to evaluate the algorithm?
It's the confidence score. It's how confident the model is that this is the correct question based on the text that it has been generated from.
Okay.
Okay.
Okay, thanks.
Okay. So, well, that's a demo of what can be done by with NLP technologies in this kind of scientific and technical domain, very connected also to the space domain. But we have more. We have well, Andrés, you tell the story now.
Okay, let me share my screen. So, okay, now.
If in the meantime there is another question, or maybe.
Okay, the first application that we're going to show you is called Space QA. So before going into the demo, I want to show you a little bit the main components. This is an application that we developed for ESA. Since, as we said before, they have, for example, when they are designing a new space mission, they produce very long documents, which are called CDF reports. And we're talking about documents with more than 300 pages. And the result is a PDF covering a variety of subjects about the initial design of a mission. So when you want to find specific pieces of information in these documents, With a traditional search engine, you will just find the document, but you will have to browse manually that document to get to the information. So that's why we thought that it will be easier if we have a question answering system that where the user just pose a question in natural language, and the system extracts from the documents the exact piece of information that the user was looking for. So this question answering system has two main components. One is the retriever, which is on the left-hand side, and the other one is the reader. So the retriever goal is to, given a question, trying to find the most related passages that are inside the documents. And to do so, usually we can use traditional sparse representations, the vector space model and backup words like in TF and IDS, which is the standard representation used in search indices like Lucene or Elasticsearch, Solar, and so on, or BM25, which is also, let's say, the traditional way to do this kind of information retrieval. And also we could use more modern retrievers as dense passage retrievers, which encode the information in the text documents using embeddings. And so the question is represented as an embedding and is compared the passages that are also represented as embeddings. So the output of the retriever is a list of passages which are ranked from the most relevant to the question to the last one. And these passages are like paragraphs. Let's think of them about like paragraphs. So the paragraphs is fed to a reader, which is in charge of reading the paragraph and extract the answer to the question. To implement this reader, we use a language model fine-tuned for the question answering task. And in our system, we have used a Roberta model that has been fine-tuned on the SQuAD dataset. SQuAD is a dataset available publicly. It's from Stanford, where you have questions, paragraphs, and the answer that can be extracted from that paragraph for answering that question. So that's the overall system components, let's say the two main components. I also have a more detailed architecture here, but I think I will refer you to the paper later on. I will share the link in the chat so that you can see the whole description of the system. And now I could better do a demo. Okay, so here have the demo that we have implemented. So first of all, we have some questions, like predefined list of questions that the user can see so that he can realize what the system can do. So for example, we can ask, what is Athena's orbit? No, Athena's is a space mission. I think it's a telescope. And here we have the answer. Is the orbit of Athena is L2. And we also show, in addition to the answer, the paragraph where we found that answer. The required orbit location at L2 provides a stable environment, and the document, which is the Athena CDF report. And also we have the score, which is the confidence that the system has in extracting this answer. So as you can see here, this is known as an extractive QA system. The system try to find the answer to the questions, to the user questions within the text. that we have extracted from the documents. This is not generative. A generative QA system will just try to start writing the answer to a given question based on the internal representation of the language model. That is of what it has learned in training. In our case, our model, what tries to do is to find the exact position in the text where the answer is. Okay. Yes.
It's so again about this confidence score. So it will be the most likely relevant start position, right? So, or the position within the passage, which is the most likely to contain the answer.
The score is the let's say the confidence that the system has that this is the right question, the right answer to that question.
In terms of probability, is the likelihood that this is the right answer. So between 0 and 1.
Okay. So as we can see, we have a variety of questions. What is Athena's orbit? But also we can ask for when is the MARFAS mission scheduled to be launched, and it will answer with the date, exact date of this, and also the score. We have other possible answers because the same question can be answered in different passages. No, but in this case, all of them are consistent. All of them refer to October 2024, but in different passages within the same document. And all of them have a very high score. Okay, let's see another type of, this is like more generic. What is the aim of MARFAS mission?
I imagine you could also type your own question, right?
Yeah, of course. We can try one, for example, what is MARFAS rover expected distance to travel, for example? Okay, I'm not sure if this is the right answer, but it says that a rover which is designed to traverse at least 15 kilometers in a straight line. And we have other possible answers too.
You have to consider that since this is, like Andrés was mentioned before, an extractive question answering system, the answers that the system provides depend on the quality of the documents that we are using in order to try to answer those questions. So if these questions are not answered in the text, we will not be able to answer it.
And I assume you would see that in the confidence score.
Yeah.
So I'm not sure why, but we are getting only answered with high scores. So let's
maybe,
try.
Maybe the audience can make a question and see.
Well, let's try this one. How far is the moon from the Earth? Actually, this is not a question that you could expect to be answered from a design document, but the system finds something. The only thing is that it says, I'm not sure about that answer. That means that the score is very low. So if you want to see what I found, but it's at your own risk, no? So it says here that is this 405,000 kilometers. And they found this information in this document, but the score in this case is very, very low.
I see.
So it's better not to believe in the system right now.
It's a way to warn the user. Okay, I warned you. don't take me for granted.
Exactly, but this is important because when you're very confident, the system is very confident. You can show straight away the answer to the user. but when the confidence score is low, you should let him know that you're not sure about it.
Indeed. On a different note, this make me think, you know, I try to play like many of us with ChatGPT and the like, and at some point I try to give to instruct ChatGPT for every answer to output a sort of confidence score before. I couldn't get ChatGPT to give a sort of a confidence or to evaluate its own response. So I think that's a good example a good point that you make, that such tools are important.
Yeah. Something that we have to bear in mind is that we developed this system the last year. I think we released it before June or something like that.
Yeah.
So what I mean is that ChatGPT just came out some months ago, and there are a lot of differences, and Jose will talk about them later on.
Yeah, but there were generative language models, autoregressive language models before that. I mean, before we actually released this system. The thing also is that depending on the kind of use case that you have, you want to solve it in you want to follow one approach or another. For example, in this case, well, we will see the differences between this and ChatGPT, for example, and we can play a little bit with that. But the use case I want to solve is probably the differentiating aspect to see what is best at some point.
I see. We have one question from Constantina asking, maybe you briefly mentioned it, but let's be sure. Did you use a pre-trained model for question answering, or created your own trained data set using domain-specific documents?
Yeah, very good question. This is the problem that we have faced when we're trying to bring all these technologies to the space domain, is the lack of annotated data. And as you know, producing this data is expensive. It requires resources. That means money and time. So what we did here was just to bring pre-trained models on existing data sets, on general purpose data sets, such as Quad, which are a question that can be answered on using Wikipedia data. And the model that we fine-tuned was a Roberta model, which is also freely available. You can find those models in Hugging Face. What we did was to create, with the help of some ISA staff, an evaluation data set. So we could actually identify which was the best retriever, because the retriever is key. If you don't have a good retriever, then you won't find the answers. It doesn't matter how big or good is your model for extractive question answering. So both components are very important. I would say that the retriever is even more important than the reader. And yes, thanks to that data set, we could evaluate them and choose the best components.
Okay, thanks.
Okay. Well, just to finish this part of the space QA, for example, I had placed a very general word question here. What is the panoramic camera mounted? So, of course, the system doesn't know what mission are we talking about. So that's why the score is low. So it says, okay, if you're talking about MARFAs, probably the answer is deployable mast. But if you're talking about this other mission, then the camera will be outside on the lander platform. But the score is very, very low. Okay. If we don't have more questions about this, I think I can move to the next.
Sure.
Yeah.
Now generation.
Okay.
Also, I don't want to take too much of your time, so I don't know if you have any hard time to leave, Andres, Jose.
We have booked until 7:30.
Okay.
And
Okay,
then we go to sleep.
Understood. Also, if we are short on time, don't worry, we can always reschedule to continue the discussion on the next topics. So no rush.
Okay, so this demo here is about a system that we developed also for ISA. And in this case, what we wanted to do is to help trainers in the quality management domain to evaluate the trainees. So because for them, they told us, okay, the quality management documents or procedures are updated from time to time. And every time that the documents are updated, we need to also train the staff and evaluate them. So the evaluation material needs to be updated too. So we said, okay, we can do this. We know how to create questions out of text, and we know how to answer the questions out of text. So this is what we have here. On the left-hand side, the input is a quality management procedure, a PDF document. We struck the passages, the paragraph in that document, and then we use two models. One model, which is a generative language model. We try two different models, a T5 and a BART model, separated. And those models were trained to generate questions out of text. For example, we use also SQUAD, where we have the three pieces that we need. We have the question, the paragraph, and the answer. So we train the model to give in a paragraph and an answer to generate the right question. Okay, that's what we did. And then once we have generated the question, we use our question answering model, the one that we had tried in the previous demo, to try to answer that question. Okay, so, and with the list of questions and answers, we generate the new evaluation material. So let's see here. The idea is that the trainer can upload a document. Let me find a document that we can upload. Okay, this will take time because these are also very long documents, and what we're doing here is try to figure out the structure of the PDF document, and then clean the text. Try to, if I don't know, but if you haven't worked with PDFs, the problem is that even text is treated like images. So you need to try to understand what is the paragraph structure. Okay, so let's see.
Yeah, I think that's also worth pointing out that here we start from a PDF and we get to a quiz. It's really good. And also I like the creativity of the trainers to come up with this use case. I think it's really interesting.
Yes. This is taking a little bit. Well, maybe while this is processing, let me try to, I will show you a little bit about how the model is trained. Wait. Okay, in this slide, on the left-hand side, you can see how the T5 model is trying to generate the questions. First, for example, we set the model, okay. You have a paragraph, and you have to try to learn the answer that we can extract from that paragraph. So actually it's a multitask learning activity. You don't learn only one activity, which is, for example, question generation, but you learn three things. You learn to extract answers, which is the part in orange. Then the model is also trained to generate the question, giving a paragraph and the answer marked in that paragraph, which is the pink color. And also T5 was trained to answer to the question. So giving a question in green and the paragraphs, then the goal was to extract the answer. So this was the way that we used to train the model.
I see.
Okay.
And so, I mean, at first, when I would think of training on multiple tasks, I would guess it's less efficient, but it seems to be actually something that is done. So can you elaborate on that? Is it actually a good thing to train on multiple tasks at once in a language model?
In the what we have seen, at least what is published in the research venues, usually multitask learning brings benefits when you're training a model. So learning to do several tasks that are related among them usually benefits your final model. I have to say that maybe this is not the case for all the cases, but at least that's what we have seen is that it's okay.
It depends on the complementarity of the tasks. Usually, you have when you are training in a multitask setting, you usually have what you call a head task, which is the lead task that you want to optimize for at the end of the day. And then you have the other tasks that are supporting, and those tasks, the idea is that they have a good fit with the main task that you want to train in the end. There are a lot of very interesting publications in this sense.
Okay, thank you.
So here the system has already extracted the structure of the document. So I'm selecting just randomly some of the sections, for example, that the trainer is interested in evaluating, and we will ask the system to generate questions. Okay, so in this part here, at the bottom, we have the list of questions that we have generated, the question score, which is the confidence of the system that this question makes sense according to the paragraph that was fed with, the answer that we have also extracted from that paragraph, and the answer score, and the model that was used to generate the question, T5 or BART, and also the paragraph where we can find the answer to that question. So just to make it easier for us, we will filter the question scores for the ones that are very confident about them. Sorry. Yes. And also we're gonna filter by the answer scores. We're gonna keep only the questions with good answers. Okay. So for example, here, the first one is, what is the team leader responsible for handling? And the answer is anomaly and or problem reports. Well, if we read the paragraphs for sure, we're gonna find that this is the answer to that question, okay? So some of them are interesting. How are spacecraft anomalies to be reported? What is the flight control team led by the SOMM that I don't know what is that? What is not required for the closure of a spacecraft anomaly report? What is listed in the mission report, and so on. So this is just a list of questions, and we can ask the system to generate the quiz for the trainer. Let's generate it here and see what we have. So what at the end in this demo, what we handed to the trainer was this, the question that he can use for evaluating the trainers, and the solution to those questions always showing the answer, but also the context, the paragraph where he could find that. And sometimes when it was explicit, the answer to the question was marked in red color. Okay, and this is what I wanted to show you. If there is any question, I'm happy to answer, or otherwise, Jose can move forward.
Not me, and no question in the chat for the moment. But thanks for the demo. I think it's really practical. We can see it. We go from PDF to PDF with a quiz, and indeed, some of these questions are really technical and can be tricky to verify if people know the right procedure. So
yeah,
good.
Well, let's make some reflection here. We've been talking a lot about GPT and all these generative and autoregressive language models and so on. So if we compare this kind of approaches, a space QA or space quiz with ChatGPT, what are the main differences? So space QA, for example, is an extractive approach, while ChatGPT is generative. Space QA and space quiz. Space QA will answer a question by extracting the answer literally from the text, and ChatGPT will generate some piece of text that hopefully will answer that question based on its internal representations. Both are query adaptive, so they depend. They leverage the content of the question in order to provide an answer. Space QA is knowledge base centric, while ChatGPT has been trained on an internet scale. Space QA is knowledge centric because it depends on the document of collection of documents that you have available in order to answer the questions. Both are fine tunable with additional label data. The amount of reasoning that we do here is very limited because it's extractive. ChatGPT may do more advanced reasoning, but an important thing here is that space QA and space quiz are factual, while ChatGPT may hallucinate. What does this mean? What it means is that if we make a question to a space QA, it will reply exactly what is written in the text. There's no way that it will hallucinate because there is not generating any text. And also in the case of space quiz, where we are generating a question, this question, we make sure that the question is factual, that it can be answered by using also, by trying to have a language model answer that question against the document where the question was answered for. So you are giving me this question, but can the question be answered? Yes, no? Well, if it can be, then it's not factual. Okay. But by using this confidence score that we have seen throughout the demos, we are providing some kind of justification that the answer is correct, or how confident we are on the score. When we are using models like GPT, we don't have that confidence score, not because it's not possible, but because the system is not offering you this kind of indications. Space quiz work on corporate data, in this case, documents from ESA. ChatGPT has been trained on all over the documents from all over the internet, including also documents from social media that may have privacy preserving issues. And this is something that will require requires investigation, requires a lot of attention, because it may be a source of trouble in the future. Also, here we're using a lot of open source technology, while here ChatGPT is connected to Microsoft, which you will have to pay a license at some point. So that gives you an idea of how these two things compare with each other. But maybe something that we can do is to see what happens if I take a question from the demo and try and ask ChatGPT if it can answer question. Let me see. For example, this one, how much does the Mars fast rover weigh? Okay, let's go with ChatGPT. I mean, ChatGPT is probably gonna provide some kind of cool answer. Oops. But let's see the differences between one model answers and the other. If we are lucky because of this time. Okay. That's, okay. I'm gonna give it some context. Okay. I'm going to make you a question about the space domain. So let's see. Sure. I'm happy to help with the questions you have about space. Okay. How much does the Mars fast rover weigh? I'm sorry, but I'm not aware of any rover called Mars fast. However, there's a NASA Mars mission called Mars 20. Okay, in this case, ChatGPT has been trained with a crawl of the web, which is information that probably doesn't contain the information about Mars fast, which is described in as an internal document. So, of course, it doesn't have a lot of information to answer this with. Now, if we can use another question. What is Athena's orbit? You see, in this case, the answer is pretty good. It's actually giving us, in a generative way, it's giving us an answer which is equivalent to the answer that we would obtain with SpaceQA. What is this? Yeah.
Indeed. Yeah, I think it was L2 indeed.
L2, yeah. Okay. Oops. Here we are. All right. So you see the difference between an extractive system and a generative system, and all this. I think I also have other questions here that we made yesterday while we were preparing this. For example, yeah, we asked when is Mars fast scheduled to be launched. Here I didn't know about Mars fast. What is SPICA, which stands for the Space Infrared Telescope for Cosmology and Astrophysics. Here the answer is correct. Of course, how far is the moon from the Earth? This kind of questions are more the most likely ones to be answered by ChatGPT because it doesn't require a lot of specific knowledge on the topic. This is everywhere, right?
Yeah, it's everywhere on the internet, indeed.
Yeah, that kind of things.
Yeah, what I have kind of a problem when using ChatGPT, for instance, and I think your demo showed it very well, is that with ChatGPT, it's always very difficult to appreciate how can you, as a human, be really confident in it. So you have really to double check and find this source of information by yourself. So this mechanism that you demonstrated that could be implemented in some tools are definitely really good. Maybe because the time is a bit running, I don't see much question. So maybe before we close, do you have anything you still want to mention really that is burning and you want to tell everybody? Or should I finish with a closing question?
let's go for your question.
Okay, so I know there are many people that are also trying to break into AI or into the space domain and are learning a lot. So with all of your experience on all of these tools and projects, use cases, talking to users, what would you say? Do you have a recommendation for a learner that would like to take the wave of NLP and work in this domain?
Andres, you want to start with this?
Yes, of course. I would say that right now, we don't have to reinvent the wheel every time that we want to do something. There is plenty of work available that you can reuse in your projects, especially if take a look at Hugging Face, where you can find many pre-trained models that are and already models fine-tuned for certain tasks. The first approach would be to try to see if those models can be applied in your domain. I mean, the space domain is very big but where you want to apply it, you need to see if they are working good or not. And if they are not working good, for sure, you will have to generate data, annotated data to adapt these models to your model. So I can tell you that generated data is not easy. That's something that nobody wants to do. But it's something that you need to be that you need to pay attention to, because the quality of the data will be key to the performance of your model.
Yeah,
that's.
Yeah, I would also say that I mean NLP and AI is AI was the term AI was coined many years ago. NLP has been around for a long time. Trying to understand language is not a new problem, but it's a very hard one. What I mean to say with this is that right now we're in a moment in AI where an NLP where we are using a very specific technology stack. We're using transformers, we're using language models for many things because they are very powerful and can help us solve many different problems. But sometimes very simple approaches go a long way. And for example, you have an SVM for classification that is an excellent algorithm, and can help you address many classification problems that trying to address with a language model can be more costly, take more infrastructure, more time, and all this. And so the bottom line, I guess, is each specific problem that you want to solve will benefit from a specific approach, a specific technology stack. And what you really have to learn is how to determine which is the optimal approach for each case, or maybe you need to combine them, or maybe you need to come up with something innovative that hasn't been done before. Maybe you need to invest in annotating data sets. Maybe since you don't have any data at all, you will need a rule-based system. You know, it's about understanding the problem and having a wide knowledge of wide and deep of what is out there and the need for innovation for the problems that you need to solve.
Thank you very much for this closing wise remarks. I think this would help many of us. So let's close. I would like to thank you a lot, José, Andrés, for joining tonight and sharing with us your insight, how you applied NLP in the domain of space. So thanks a lot. I think people enjoyed it. Still a lot of participants in the call, even after 1 hour and a half on an evening. People are really motivated and they are all clapping. Thank you, thanks a lot. Thank you for the interesting session, people say. So yeah, they appreciate. if to the audience, our next event about AI in space will be in 2 weeks. And this time, we will talk about deep learning to understand galaxies. So stay tuned on Rocket AI YouTube or channel or on the LinkedIn page, and you will see the posts. So yeah, thanks José again. Thanks Andrés. And
well, thank you. It was a lot of fun.
I appreciate that. So yeah, keep up with finding good solution to help us building new space mission, and see you next time. Bye bye everyone.
Bye bye.